Hello, is my voice clear? Am I audible? Okay, great. So, first of all, my sincere apologies to all the participants and organizing committee, as because of some unavoidable reason, I was not able to conduct yesterday's session. So, I'm very sorry for that. So, without having any delay now, let's start with today's session. So, today we will be talking about some important aspects like how we can create an automation using IoT. And when we say automation, the very first thing what comes in our mind is let's start with our lights. Let's have our lights on and off automatically, or we can have a home automation application where once someone walks into a room, automatically that light needs to be turned on, and when no motion is detected or no one is in the room. Now these are two different things. Please pay attention to it. When there is no motion and when there is no one in the room. Now I'll explain this in quite well, as there are two types of detectors are available. One is a motion detector and second one is a proximity detector. Now, what motion detector will do, we will be having passive infrared receivers, or we can have a passive infrared sensors, like we called it as a PIR sensor. Like we used to detect some motion as it is detecting a human body temperature, or kind of a heat signature of a human. And when there is a motion, it will automatically turns on its capacitors, and then it will throw a signal whatever we wanted to switch on, or whatever the machinery we wanted to turn on, that will be turned on by that signal. So it is what it is, the PIR sensor, where it is detecting a motion. So that PIR sensor is having some limitation, like it is binded with a timer, then it is having a proximity, then it is having a sensitivity and tolerance to be set at, like sensitivity how far it can detect, and then after that the tolerance ratio, how exactly on which sensitivity it will be detecting it. So depending upon that, it will going to react. And another sensor is that is going to sense the proximity. So it is not the proximity sensor, but it is a active IR sensor, where it is directly sensing a proximity. And once a particular proximity is detected, whether it is a human or any other being, so if you have a non what we can say, any animal coming in, like your cat or dog or something, though that IR will going to detect it, and according to the code what we have set it, once the IR sensor is activated, what it's supposed to do, that functionality will be happening. So depending upon our requirement, we can use all these kind of a sensors. So if you wanted to detect a particular humans only, and then only that particular application is to trigger, then we can use PIR sensors. Even with the sensor what I'm having, it is just an entry level sensor, but we can have a industrial sensor where the capacity tolerance is much higher than the what I am having. And fortunately I'm having one of the industrial sensor as well, so that also I can take. Just to give me a minute. Okay. So fortunately, I'm having both the sensors. I'm also having industrial use PIR sensor, where its capacity is much higher than the what we are using in our prototype. So this is what the basic automation kind of a application we can do. And of course, when you wanted to detect a human detection, then you can use PIR. And there are some advanced functionalities as well. You can use ESP cam 32. that practical we will be seeing in a while, that we can use for human detection. Like if there is a human, or if there is a particular person, if we wanted to scan it, like only if I am entering in my room, then only lights will be on, or AC will be on, or whatever the application you wanted to use in a home, that you can do. Or in your office environment, when you are entering into your cabin, then only certain application needs to turned on, or it should alarm or something like that. And someone else is coming up, then it will be as it is, it will not turn on anything. So that kind of functionality if you want, then we can use camera sensors. Like for that we can have ESP cam 32, which can be detecting on the machine learning model. So ESP cam 32 is having a built-in a very low category of a machine learning model, but it still can distinguish, or it can detect humans. So it can detect face, it can detect humans. So once it is detecting a face, we can customize it to detect only a human face, male, female, human face, only the human face we can see. And later on we can give a profiles, like this is my face, this is my photo, so this is my profile, and according to the profile it will going to react. So the same principle is worked in your biometric attendance system, where you are having a camera mounted on it, and once you place your photo, or when you place your head in an appropriate angle, it will capture a photo, and accordingly it is going to react. uh,
हेलो सर, आपका माइक ऑफ हुआ है।
वेरी सॉरी, मैंने म्यूट किया था उसको, क्योंकि मुझे एक कॉल आया था, तो मैं उसको डिस्कनेक्ट कर रहा था। Okay. Now, when you are using a particular ESP cam 32, then you can give a profile, like when you are the same profile which is set in your biometric attendance system, where you are just standing on to a front of that camera. That camera is taking your picture and relating that picture with the database what it is having. So maybe before 2 years or 3 years, you have given your photograph in there. So there can be some what we can say hurdles, like the photo what that camera was taken at 2 years back, and the actual face right now you're having, maybe it can be a difference. Like this face can be a thinner, or this face can be a healthier one. So depending upon that, so it is totally depend upon how exactly the camera is positioned, and what kind of a camera sensor they have used, and what kind of a learning model they have used. So it is not always that every camera model is having machine learning model set it on it, but still we can utilize it. So similarly, right now also I'm having a mi camera, external mi camera connected to my laptop. So it is also having a feature. So camera is not having a feature, but my Windows 10 is having a feature. Once I open up a camera application in my Windows 10, it is start looking around. When a human face is detected, then it is marking it with a rectangular shape. So it means that it have detected a face. So that face detection is already enabled in most of the application. So similarly, if you wanted to create that kind of a profile, so once someone known, or some profile is known to that system is entering into a room, then only certain situation needs to be triggered. Otherwise, whatever the situation was there, that needs to be remain same. So that kind of application we can develop. So right now what we will be developing a simple relay application, and later on I'll be demonstrating it with the ESP cam 32 as well, how exactly ESP is getting interfaced with your Arduino ID, and then what kind of face detection or camera or live streaming we can have. So that we will be taking it soon. So for this demonstration, what I'll be using is I'll be using our Arduino Uno. Then we will be using some relays. Now, specifically, I'm taking this application because this application can be simulated in your Tinkercad simulator as well. So first of all, let's understand what components we will be requiring, and then I'll turn on my screen sharing and I'll show you the design what I have designed in Tinkercad. And what we can do is, along with me, even you can create that same design on a Tinkercad and you can experience the same way what I am doing here, right? So for creating that automation project, what we will be requiring, or the simple kind of application, what will be requiring, will requiring a development board. It can be any development board, maybe it is a Uno, or it can be a Nano, it can be a Raspberry Pi. If this case is in the Raspberry Pi, then Arduino IDE will not help us. We need to log in through Raspberry OS, and then there we need to give a code. So to be on the same page, we'll be using Arduino based microcontrollers, so Arduino based development boards. You can use any of the development board. Then we'll be requiring relays. Now, the first thing, what exactly relay is? So this this is only the relay, the blue one. If you are seeing, this is the relay. So what this relay will be doing, this relay is a mechanical or electromechanical instrument which is taking a high voltage input, and it can drive through a low voltage input. Means what? This Arduino Uno or this development board, ये जो सारे है, ये सारे आपके low voltage devices है. So these are the low voltage devices. Now whatever the instruction we are forwarding through the low voltage devices, that needs to be triggered here, and the high voltage instruments like your AC or your light or something, like here I'm having a one circuitry, so I'm having a light bulb and I'm having a simple on off switch, so that circuitry is already created. So this circuitry will be turned on. So depending upon the load, so typically we are having 230 230 volts current in our home or in our office. uh, it is just a typical case in India. So according to the whatever the semantic you have for your electricians or what they have made, so on the electric circuits you will be having most probably 230 to 240 watts. So that is the or that is the incoming voltage you are having. So we need to take that kind of a relay, so this relay can able to hold that kind of a current, or that much of a current, that much of a electricity. So this is the 230 volt in, even it is having larger than that, it is a 250 watt volt of a in. So the specifications are already written over here. Even when you are going to buy these kind of relays, you can get it. So you can get only the relay and you can make the rest of the circuit if you know PCB design and PCB circuitry, or you can get this kind of a ready-made relay boards. So this is a relay board. Now you can have relay board in different configuration. You can have a single relay board like I'm having over here. So this is a single relay board. Then you can have a four relay board, like here. You can have eight relay boards. I'm having it over here. This is the eight relay board. You can have two relay board, this one, or you can have 16 relay boards. So you can have 16 relays attached to this one. And the principle is one relay is equal to one appliance, or one relay is equal to whatever the application you wanted to perform, that can be controlled through one relay. So that is what the recommendation is. But sometime if you are not having multiple relays to control multiple applications, so we can just twist that wire, and you can use a single relay to control two or three applications or two or three appliances, but it is not recommended because there is a chance of short circuit or destroying your relay board or destroying your application, the main appliance application, or can disturb the entire power supply. Maybe this can be happened. And this is a ceramic relay. Outer one is a plastic mold, and under that there is a ceramic gears and the metal gears. So once you give a power to the relay, you can hear a sound like tuck, it's kind of a sound you can hear. So that is the mechanical switch which is turning on, saying that this relay is now turned on. Now we can have different relay configuration, as I said. So this is a 5-volt input relay. So the entire relay board will require 5 volt to operate, but it will going to manage your 230 volts of a appliance. So the current which required to operate this relay is a 5 volt. 5 volt पे ये काम करेगा, and then it will be what controlling your appliances which is having a in power supply as 330 or 340 watt. So ये जो है ये 240 volt तक का power distribution कर सकता है. Now these relay typically comes with the configuration like if you can see over here. So each relay is having 3 ports. So the middle port is a 90% common port. So this common port will be attached to the main power supply. And then we can have a commonly open and commonly closed port. So it can be uh, shown in this kind of a diagram. So if participants are from electrical background or they are having a little bit of a electric know-how, then they can understand this circuit diagram. Or in some relays there is characters which are displayed like this. So this relay is having, one is on, if you can see. Let me pin my camera so everyone can properly see. So you can have one is no, then another is common. So I'll put like this. Okay. So one is no, then one is common, and then another is NC. So the middle one is common, then first one is normally open, that is NO, and second one is normally closed, that is NC. So normally closed means what? Once you put your appliance wire in normally closed port, then it will shut off the power supply. And if you put the normally open port, then it will flow the power supply. Now what will happen in this case? So we wanted to halt, or we wanted to control the power supply depending upon the situation what we are creating. So situation will be like, we'll have this PIR sensor. So once the activity is detected on the PIR, then only PIR is going to trigger. Once the PIR pin is high, means the PIR pin is activated, then only this relay needs to be activated, means this relay needs to be on, and whatever the appliance is connected, that needs to turned on or turned off. So you can make the setting according to you. So if the PIR turned on, then whatever the even the fan which is just on, that needs to be turned off. That you can do, or you can do in a general way, that once it is turned on, then fan needs to on. When it is turned off or the motion is not detecting, then automatically fan will switched off. So that kind of application we can do. So it totally depend upon how the wiring you are doing. Now on the relay you can have some pinouts. So this relay is also, this is the 8-port relay. So 8 relays you can see. So on the 8-port relay, you can have one as a ground and one as a win or VCC. So win or VCC will require 5 volt in, and then other pins are the relay pins. So each pin denotes for one relay. So you can define like pin mode relay 1, pin mode relay 2. So it means that in your program you are defining what relay supposed to do which work. So similarly, the same thing is with this one. So only the thing is, I'm having a different configuration again in the relays. The two what I have shown you right now. So this one and this one, the blue ones. So these are the 5 volt in relays. I'm having a 12 volt in relay. So there are 5 volt, 12 volt, 24 volt, and 48 volts of a relays so far, which are available in the current market. So depending upon your in current, so what type of the device you are getting, that kind of a relay you can get. Even these are the controlled relay. You can have electrical relays which are much bigger than this and can control the heavy loads. So the high tension load they can connect. Okay, so let me share my screen so I can show you the design or the diagram how we are going to connect our devices and what will be the code for it. and I'll explain the code again. So those who are very new to IoT, and though those are not familiar with the code, that also I'll take. So what kind of variables we are using, so how to place them, what needs to be defined, what needs to be taken as a output, what needs to be taken as an input, what needs to be taken as a high, what needs to be taken as a low, so that we'll see. Okay. So here is a diagram, or so what I have connected. So I have connected a one more sensor. So here is a PIR that we already saw in day before yesterday's session, and here it is a relay, and here it is a bulb. So you can get all these components, and I have a power supply over here as a 9 volt of a power supply. But totally, it is totally depend upon what kind of devices you are using. So accordingly, you need to choose your power supply. Now we need to take in mind that this PIR sensor at least requires 4 to 5 volt of a current to operate. Even it can work on 3.3 volt, but it is recommended to provide a 5 volt input. So the accuracy or detection ratio is good in in a 5 volt current. Then this relay is of a 5 volt of a relay. If you wanted to see, then you can see over here. So actually this is a 24 volt of a relay, but this is a simulator, so it can work on a 5 volt as well. So let's assume that this relay is a 5 volt relay. So it is having 3 ampere as a total ampere cycles, current cycles, and having a 24 volt direct current, and even it is having 3 ampere 125 volt of a AC current. So then we are having a general light bulb, and then we are having a 9 volts of a battery. And here, if you can see, this is a small sensor. So this is a LDR sensor. If you remember at my first session, I've shown you a LDR sensor. Now what the LDR sensor is, so LDR sensor will check the light. So if it is having a light which is configured, so once it detected a sunlight or a light, it will directly turn on, and it will send a signal. And once it is not having any sunlight, then it will automatically turn off. So in this simulator, if you wanted to turn it on, then we need to click on this. So once you click on this while running the simulator, there will be a slider. So once you slide it out to the sun sign, that means that you're giving it as a sunlight. So once it detected a sunlight, it will automatically trigger a signal to our Arduino that I have detected a light, and once the light is detected, automatically relays is going to be turned on. Now the entire circuit, if I can explain you, uh, the entire power supply will go to the relay. uh, which power supply? The bulb's power supply. Your Arduino requires extra power to work as on the simulator, but once we are working on the real time, what we will be doing is we will be taking up a sensor shield like this. So this is a sensor shield. So what the sensor shield will do, will stack the sensor shield here on Uno like this, and then we'll power Uno directly. So once we power Uno directly with a 12 volt 1 ampere power supply, as my relay will require 5 volt, my bulb will require 5 volt, and then my PIR is also going to require 5 volt. So here relay will be step on step down, so it will require less power as compared to my bulb. So even here, my bulb is requiring 5 volt, but there I'll be directly giving a power supply. So once I'm having the circuitry, so one power is directly going to the bulb, which is coming directly from main supply, and that main supply is again triggered to the relay here. तो इस हिसाब से उसका पूरा सर्किटरी होगा. सो एक आपका रिले में जाएगा, एक आपका डायरेक्टली बल्ब पे जाएगा. सो सिमिलर काइंड ऑफ अ थिंग. सो यहाँ पे सेंसर शील्ड का यूज हम करेंगे. सो this sensor shield will have extra pinouts to work with, so I can have my PIR and my relay attached to the single board, right? So here are the diagram. So consider this 9 volt is direct your power. So the positive end of direct power is attached to the relays main, that is the common port here, the middle port. So that where we will be attaching, that is the main current. Then the negative current, or we called it as a neutral in general electrical language. So the neutral current will pass to the bulb directly. Now the another end of the bulb, that is the current which bulb required, that is the mains to the bulb, is again attached to the relay. Now here that relay needs to be controlled. So the relays pin, here it is the relay pin. If it is a relay 1, then there is here it is a relay 1 pin that needs to be attached to the 13 point port, or maybe any digital port you can get. Here I have attached to the port number 13, and the neutral one will go to ground. So here is a ground which is here. So in the diagram, if you can see, there is only a one relay, but we are having 8 relays, or we are having 4 relays. So the entire board will have a common ground port. So there will be only one ground, and there will be only one VCC port. So the VCC port will go to 5 volt, and ground port will be going to any ground of the Uno. And then each relay pin will be triggered with the each digital pin out of that Uno. Same case with PIR. One is your signal, another is ground, and one is your VCC. Same with LDR. LDR is having only two pins. So one is a negative and one is a power. So power will go to 5 volt, and a negative will go to ground, or it is already short with the 10 k's resistor with the ground, and another is controlled over here. So in our actual implementation, I'll be not using LDR right now, but this is just to give you information, like we can interface more than 2 or 3 sensors with the board with the using our Arduino sensor shield. That's why I opened this connection. Now maybe this diagram looks what we can say critical, but if you move to the code is very simple. If I click on the code over here, so here what I am doing, so let's debug this code one by one. So this entire code is written in C. So those who know C programming well, of course you will be knowing the C programming. So this is entirely into a C. It is not an embedded C, it is just a C. Now here it is the one variable called relay. No, there you can name it as you want. I have used it as a relay number. So relay number is an integer type of a integer data type I have given to the variable. So I have stored port number 13 in that. So it my program will know if I wanted to operate relay or where I wanted to go. So I can go to the relay number 13. So that is my port number 13. So there I can activate the relay. Then I'll have a PIR, that is an input PIR variable, which is triggered to the port number 2. Then I'll be having a value which is set it to 0 right now, because later on I'll be calculating a value. Then I can have a result do sensor LDR. So LDR I have used, that's why I'm using the uh, LDR. Then I can have that LDR attached to the A0, because LDR is analog sensor. So analog sensor needs to be attached with the analog port. So any port can work, but I started with the A0. Then this is the main program or the main section of your code. So that is void setup. In C, we are having void main or int main according to the what program structure we want. Accordingly, we'll give a data type. So here it is a void setup. Instead of a main, it is a setup. So what I need to do in this, I need to declare the main functionality here. So I'm declaring a main functionality like pin mode. So I'm having the pin over here. So what will be that mode? So the pin mode will be relay no. So I'm taking up the variable which is output. So that port number 13 is the output port of my relay. Then input PIR means what? I need to collect the sensor data. So that's why it is an input. So once my PIR is detecting any movement, then it is a input data. So that's why I have defined it as an input. Then LDR is also input. Once it is detecting the light source, it is what? It is an input. Then here it is. I wanted to print something because I wanted to give a connection. So that is serial dot begin. Once I give a command serial dot begin, it will turn on my serial monitor. So if I turn on over here, where it is, yeah. So if I turn on over here, so it is automatically turning on the my display. So the bird rate is 9600. I'll come on the bird rate when we are taking up with the protocols. That time we will understand it very better way. So that time I'll take up the better bird rate. So generally when we are using Arduino, any kind of a development board, that time we are using bird rate of 9600, where we are not having any WLAN or any wireless sensor attached to it. Once we are attaching a wireless sensor, for that sensor we are giving a serial pin for 11,000 of 11,005 to 00 bird. So there is a ratio of it. Depending upon that, the frequency it is going to match and the output is going to be printed. So here it is a serial dot begin for printing your output. So serial dot begin 9600. I'm opening up my serial monitor. Now this is a void loop. So this is a main function of your main code, where we will be defining our actions. So my action is, now here is a value. I need to store a value of what? Digital read input PIR. So what it will do is it will going to collect the input what my PIR is giving. That data needs to be stored. So digital write and digital read is used to read and write the information. So here it is digital read and digital write. Then result do sensor LDR. So here is the LDR. Again, it is analog read as it is the analog sensor. So that's why the analog read is over here. And then I'm giving a statement. If the current is detected, means if the motion is detected, then turned on relay, else turned it off. If LDR detects the light, turned on relay, else turned off. So similarly, I have given the statement over here, or else as it is, वहाँ पे कुछ नहीं होगा, and there will be a delay of 500 milliseconds or the seconds, and then again this loop will get executed. So this is what the code is. Yeah, clear till this point? Any question, any doubt? Okay. Okay. Now let's start our simulation. Once we start our simulator, now it is started. Now if you can see, everything is on the normal page. Our PIR is not detecting anything. Our LDR is not detecting anything. That's why light is turned off. So imagine that your cabin lights are off. Now once I click on the turn PIR, and if I do the motion, now the light is turning on. It will wait for 500 seconds, 500 milliseconds, and turn it off again. And that loop is again executed. The if statement is again executed. Again, motion is detected. Again, 500 milliseconds means exactly a 5 seconds. Turned it off. Similarly, there is a LDR. Once we click on LDR, there is a slider, shows the sun mark, means the light we need turned on. So here is a sunlight. Once sunlight is detected, supposed to turn on. Why it is not going, I don't know. So it's supposed to turn on our light. So let me run the simulation again. I'll just slide it up slowly. Maybe something wrong with the uh, cabling part, but okay. The main thing is, once here it is, once the motion is detected, it is automatically turned on or turning on the lines. Once I'm leaving that area, and it is automatically turning off. So let's do this with the actual relays. So what we will be requiring, will require the actual relay, will require Arduino Uno, and will require a code. So the code is, already I have a one code which I have already created, and here in this code, instead of only one sensor and only one relay, I'm using multiple sensors. So I'm having four PIRs, and I'm having eight relays. So I'm using this eight relay panel, but here we will be not utilizing any all relay pins, as I'm having only one applying to turned on. Okay, so what I'll be doing is, to show you the exact circuit, I'm just tilting my camera down so we can see our devices properly. Okay, are the devices properly visible?
Yes, sir.
So what I'll be doing is, here I'll be taking some jumper wires and I'm doing the connections. So I'll be using one for VCC, another for ground, and I'll be taking up this one, that is the N1, that is the relay 1 in 1. So I'll be requiring three cables here. So the first one is ground. I'll be placing ground over here. Another one is relay pin, and another is VCC. So VCC is the last port. Similarly, now here, instead of placing all the wires to Uno directly, I have sandwiched it with sensor shield. So I'll be using sensor shields port. So here are the digital ports of sensor pins. So you can see now, first row is in defining ground, middle one is voltage, that is VCC, and last one is S, that is for the signal. So our ground pin for, so our relay will go to ground, VCC, and according to a first in pin will go to signal. So depending upon which number you have defined in a code. So here in a code, I have defined my relay pin from sixth port. So here we need to see there is a marking, number marking. So these are the ports. So if you can see over here, here are the number marking, 0, 1, 2, 3, 4, 5, 6 till 13. So I can use any of the ports. So once I interface my relay with any of the port, so that will be communicating with the actual port here. So in my case, this is relay pin 1 is attached to port 6. So here it is a green cable. So green cable will go to S of port 6. So here I can see port number 6, 4, 5, and 6. I've attached 6. Then VCC, which is a brew, to the middle point. We need to be very careful when we are using jumper cables. You need to connect it with the right port, otherwise your mm, sensor will not work. Okay, so the first connection is successful. Another connection needs to be done to Pir sensor. So again, I'll be requiring three wires. take these three wires like this. This much easier way. Okay, so according to the PIR, the first wire, which is black in my case, is VCC. Middle one is data, that is signal, and last one is ground. If you can verify, here is the marker. You need to place the dome back, otherwise PIR will not going to detect the movement. So here what I'll be doing is, according to my code over here, my first sensor pin, means the PIR pin, is on port 2 of my Arduino. So I will take my sensor pin, which is brown, will go to second port, then my VCC, which is black, go to a middle port, and finally ground. Okay, so here my connection is with my Arduino is completed. Now we need to interface this with our actual load. So that actual load needs to be implemented here. So what I will be doing is, I'll be taking up my connection. Okay, so here are our connection. This will go directly in. Now we are having one common port and one which is going to the uh, commonly open or commonly closed one, and we are having a button to illustrate, like we are having this bulb attached to the main circuit, and once it is turned on, if the relay is not powered on, then automatically you can eventually get the connection on and off using switch, the normal button switch. And if the relay is on, then this will not work, because the control of the entire bulb sequence is on the relay. We need to be very careful while working with the direct currents. Here it is. I'll using my connection here. I need to see port N1. Here it is. I will give this commonly on. Here it is. It will go to commonly on. We need to secure it firmly, and another pin will go to commonly off. What will happen if I put my neutral cable to commonly on instead of, means commonly closed, normally closed instead of normally open? Only the thing is, once we give a power to relay, your light will turn on if the connection is reversed. That in that case, once PIR is detecting a motion, it will turn off your light. So the troubleshooting is, you need to reverse the wiring. So if we are attaching our neutral to commonly close, and if our light is turned on and PIR is activated, it is turning off, then we need to reverse it to the commonly open one. So here the circuit is completed. Now what I will do is, I will reprogram my Uno here. So I'll go to my code. I will select Arduino Uno, select the port, which is a 14, and I'll burn this code. Okay, if you notice, my PIR is detecting now a motion. So I have given a visual confirmation over here. So once it is detecting a motion, it will give us a information that it is detecting a motion. Like if you are seeing over here, motion detected at PIR 234, as I have given the code. Just a moment, I'll just turn off the auto scroll so you can see it properly. So as it is mentioning, I have used more than 3 pins, so that's why I'm outputting all the sequence. So here it is no motion at PIR 1 2 3 4, and the 4 which is connected right now, because 1 2 3 is not connected, only the fourth one is connected over here, the PIR pin 3, which is a 4 which is connected. So it is outputting that signal, and once the port is detecting the motion, it is automatically saying motion detected at PIR 1234, as I have given a common port to all. That's what it is. And if you observe over here, once I am uh, placing my hand like this, it is detecting a motion and it is turning it on, and by having a delay, it is turning it off. Right. So similarly, what we can do is that test is completed. Now let's give a direct power to our bulb. So it's supposed to turned on and turned off sequentially when it is detecting my motion, and I'm continuously hovering my mouse and moving my hand over here and there. That's why it is detecting my hand's motion, and because I'm moving my mouse, again my hand is getting what we can say motion at this place, so it is again detecting the motion. So let's turn it off. I'll take my bulb here so you can see it properly. I'm giving it a power. Now we can see my bulb is turned on or switched on. Why? Because we have not activated relay yet. So once I activate my relay, now if you can see, it is detecting my motion and turning it on. Now if you observe, my relay is turned off, so it is giving me power. And once it is detecting the motion, it is turning on my light. So it means what? I need to reverse this one with commonly closed to commonly open. I have actually connected it to commonly on, so I need to normally on, so I need to give it to a normally close. So this will work pretty fine. So I'll just remove this. Oops. And I'll place it here. Okay, all set now. And give a power. Now if you can see, and we'll give power here as well. Once it is detecting any movement. Yes, it is when it is detecting a movement, it is turning it on, and again back and forth, it is turning it off. Are we clear till this point? Any question, any doubt? Now let's try this circuit on your Thinkercad board. Just log in into Thinkercad, take all the components from component list and wire them like the wire I have given, the design I have given. To color all these wires, once you take a wire like here, you can have a color, you can give it any color you want, or you can just have a one colored wire. But if you have a one colored wire connected to every sensor and every module, then it is very difficult to identify which cable is going to which port, and if you wanted to troubleshoot anything, then it is very difficult. Now here, if you notice that I am not using, or the simulator is not giving me a proper functionality to use any sensor shield like I'm using in the actual application. So that's why I'm shorting both the 5 volt connections, like the one connection going to the relay and another going for a PIR on a 5 volt exactly. So I'm putting the two wires on a 5 volt. It is not recommended, but due to lack of other devices on a simulator, we can do. Similarly, on ground as well, I have given the same. I've attached three grounds, though I'm having ground over here also. I can do like that, but for looking at pretty, I've used only single ground to ground it, because ground is ground, it is going to ground your signal. So it is okay if you twist your wire and put it into a single ground, but it is not advisable to put it in a single power source, right? So if you required a power source like a 5 volt of a power source for more than one sensor, and that sensor is not getting enough power through 3.3 volt, then it is better that you can use a sensor shield or expansion shield or something to operate on it, right? So yes, give a try and let me know, um, is you successful in that. So are we trying, or we'll move to the next demonstration? What we can do? Yes, participants, you are trying it, you are trying that circuit, or we'll move to the next demonstration. And yes, another important part, when you are searching for relay, then you might see this relay as well, DPDT. So you need to choose SPDT relay, don't choose DPDT relay, as SPDT is having a functionality like it can get the low voltage current to operate, and it can counter the high voltage. But DPDT is a straight through kind of a relay. It requires high voltage and high voltage in and high voltage out. So we'll be working on a low voltage in and high voltage out. Or for your convenience, what I will do is I will share this, or I will download this sensor diagram, and even uh, I will export it here, and I'll put it in a chat so you can directly upload the same. Even it is having a code. Okay, on a chat it is not going to. So what I will do is I will upload it on a WhatsApp group so you can get this diagram and the code as well. Right. So shall we move to the uh, another demonstration? If you all not
Yes, sir.
okay. So for another demonstration, we'll require a cam 32. So let's see how we can utilize ESP cam 32 with the camera module, and we can have a basic application ready for live streaming your video and even audio. So you can have a microphone sensor attached to ESP cam 32 to record your audio and video, both the files. Even it is having a very good functionality, like it is having a SD card slot just underneath the camera module, so you can place up to 8 GB of a memory card. So up to 8 GB, which is stated in its data sheet, but I've tried it with the 16 GB. It is working fine. So you can have it. Now if you are going to buy ESP cam 32, then it will come with the two modules. One is a AI thinker module and another is a simple ESP 32 module. So what is the difference in it? So AI thinker module is enabled with the machine learning approach, and you can connect AI thinker chipset with your model and can do any of your data collection or visualization or any kind of a modeling task very easily on that chipset because it is tuned for that. But if you just wanted to create input file, like you wanted to take a continuous streaming, or you wanted to store that video or something, then you can use a simple board as well. So once you are going to purchase for it, then usually you will get this kind of a simple one. Even I'm having a AI thinker, but I don't know where I have put it, and I'm having a lot of sensors right now with me, and sometime I lost in that. So we'll take up with this ESP cam 32. So as this is the extension of Node MCU, so it is carrying all the functionality and all the what we can say connection types as good as like your Node MCU only. But only the difference is Node MCU is having much more pins than this, so you can have a ESP32 expansion shield, like the sensor shield here we are using expansion shield to expand its reach. But the main use of ESP32 is to have a video camera. Right? So let's see. To program this, if you can see or if you notice, there is no input section, so we cannot place our cables, or we cannot connect it with the cable. So for this we'll require a external USB to TTL. TTL is what? The pin outs. So USB to TTL or RAT converter. So here I'm having it. Here I put it. Okay, so this is the USB to TTL converter. It is having both the functionality. If you see this jumper, so this jumper is set on a 5 volt in, so it will pass a 5 volt into the board. So the boards which are required to operate on a 5 volt, they can give a 5 volt. Even there are some boards which are operating on a 3.3 volt. So if you wanted to pass 3.3 volt, just take out the jumper and place it to the another pin. That's it. So here it is. Now it is switched to the 3.3 volt, and that rating is already written over here on the board, so you can accordingly change the thing. So this ESP cam 30 requires 5 volts, so I'm putting it on to 5 volt. Okay, so yes, now it is on a 5 volt. Now here if you can see, we are having a lot of wires to connect. One is I'm not able to see it properly. Okay, one is DTR, then RX 100, TX, then VCC, then we are having ground. And okay, so we are having ground and all. So what we'll be requiring, will require exactly four pins out of this. One is ground, one is VCC, and another one is RX and TX. So that will be going to this one. So let's interface this. For interfacing this, again will require some jumper cables. Just take it from here. Now first one is RX and TX. I'm putting up the RX, TX. Then I need to have ground. I need to have VCC. So I'll require one more cable here. That is for VCC. Okay, that is done. Now the most important part on ESP-CAM32, you need to sort ESP32 for a booting mode. So how we can do that? For that we'll require a ground and IO0 pin to be attached. Okay, so here it is. So one is ground, and you have to loop it with IO pin like this. You need to give this one is the IO pin, and I have made a loop. It means that it will turned on the flashing mode and it will able to receive our program. Then from here, first one, the black, this is the VCC. VCC will go to the VCC end. So VCC will go to VCC end over here. Then ground will go to obviously to ground. Ground is black in my case, so it will go to the ground. Now here are two ports. One is UOR, that is receive on ESP32, and UOT, that is transmit. So we need to do exactly a reverse order. So the RX of TTL converter will go to TX of the ESP-CAM32. So it will go to here. So let me take the wires out. The red one will go to T, then brown will go to here, and it will go to here, and ground. Sometimes it is very difficult to place all the pins on a single side. Okay, now the connection is done. Now we'll take the micro USB cable to program this. We'll give a power. Okay, so once everything is good, then you can see this LED which is turned on, showing it is getting a proper response and proper power. So here I'll go to my presentation. So I'll pin my presentation here. I'll just unpin it. So on the board, what we need to check it, we need to go to boards. If you remember, I have shown you how to install boards from the boards manager, and there we updated ESP32 Arduino board. So here it is a ESP32 Arduino. We need to go to here. Now we need to select AI Thinker, as this one is of a AI Thinker chipset. So it needs to be here somewhere. Yes, so you can see AI Thinker ESP32-CAM. So this is the board what we look for. Once we select the board, this is the example of the board from this code. How you'll be getting this code? You need to go to File, go to Example, then you'll see ESP32 over here. Then you need to select Camera, and on the camera you need to select Camera Web Server. So this is the entire code for creating a Camera Web Server. So this you need to now upload. So here you need to select the appropriate CAM port, and then you need to click on upload. Oh, and the very important part, before uploading on it, you need to give your Wi-Fi's SSID and password, as this is a node MCU's extension. So this will obviously have the same property. So it can be in a station mode and it can be on a access point mode. So currently it is on a access point mode. So what I will be doing is, I'll be disconnecting it. I'll be giving the Wi-Fi name and the password for it, and I'll see all the connections, as these all connections are properly done or not, as it is not getting the TX is blue, which is connected to. Okay, TX is brown, TX is okay. Let's have a try. Oops, it is not uploading a sketch. I'll try it out with the different one. Yes, now it is writing it, if you can see. So actually it was on the 5 volt, so I'm giving a 5 volt in, so it is not getting a 5 volt in for a uploading the what we can say code. So I've switched my power supply from 5 volt to 3.3 volt. Now it is taking up. So once it is done, we need to see for a connection on baud rate of 11,500 5200. So once baud rate is captured, you will notice one IP address is assigned to ESP32. So we'll browse that IP address and we can see the ESP32's portal. Okay, now this is done. I'll click on reset tab. So reset tab is behind it here. I'll just press it once. Once I press it, it will turn on a LED and turn it off again. I'll open up my serial monitor. I'll go to baud rate of 115200. Now here I supposed to get information. Before that, we the loop what we have created that we need to remove, because this loop is only required to program the board, but to operate it this loop is not required. Now here we are getting something, detecting camera not supported, right? Now let's power it off and power it on again. Select on. Okay, let's see. It will take a while. Maybe I'll try it again. Okay, maybe some kind of a camera error is there. So to troubleshoot it a bit, if I remove these two cables, it happens sometime as these are not that well cameras, because I placed it in other sensors. So might be that camera is damaged over here. I need to take out another sensor and we need to do the same again. Allow me a 2-3 minutes or more. I'll just try it once. Okay, maybe I'm having a faulty camera right now, so I'm having another ESP board with the camera. So what I'll be doing is I'll be taking it in after our lunch break. So before moving to the lunch break, I would like to show some other material what I have designed. Just unpin it, pin my. Okay, so here we are having the robotic arm, which is 3D printed. If you can see, there are servo motors which are attached, Now, the servo motors are the lightweight motors which can have a metal and plastic gears which can move a bit. Now, depending upon the rotation of the servo motor, so this servo motor which is having a metal gear inside having a 360 degree of a rotation, so it can almost rotate it 360 degree. But I'll be not rotating it 360 degree, as this is not my intention to do, as it needs to hold the position till this. So what I have did is, instead of taking up the 360 degree of a rotation motor, I have taken up a 180 degree of a rotation motor. So it can give me this kind of a functionality. Then here is a second servo motor which I have placed. Again, it is of a 180 degree, and again in a bottom also I have attached this servo motor. So this is 50 to 80% completed project. uh, I'm trying it to complete it within a time so I can show the functionality of it. So all the sensors and all the servo motors will be connected with Arduino Uno, and using a mobile app, Bluetooth mobile app, will be controlling the entire movement of that robotic arm. And this is a gripper of the robot arm. So it is attached to it, and all these small parts are 3D printed. So I'm having a 3D printer, Ender 3, a basic 3D printer. So through that, I printed all the parts. So the main implementation of this project would be, I'll be creating a one prototype which will hold the gripper mechanism, can hold up to 5 kilograms. So it will have a capacity of holding a 5 kilogram, and these are a very lightweighted yet a very strong 3D prints. So I've used PETG, that is a kind of a filament we get, which is known for its strength. And after a PETG, there is a carbon fiber, of course. So carbon fiber is more lighter, that we used in these quadcopter frames and to create the propeller. So now this propeller is a carbon fiber propeller, but we have not 3D printed it yet. We have directly purchased it, but we can 3D print them. So carbon fiber is the very lightweighted yet very strong kind of a material. So we can use it in various projects. So what we will do is, we'll just have a lunch break. I know it is a bit early, but we'll definitely come back in a time. So I'll demonstrate it further. And that meanwhile, I'll figure out what's wrong with my ESP cam, or I'll take up the another device what I'm having, and then I'll demonstrate it. Even in a relays session, I was talking about the industrial PIR sensor. So this is what we usually see in a PIR sensor, which is directly embedded to the floor lights. So this is what this is, light, quite bigger PIR sensor, and underneath it, it is a direct cabling here, and inside it there is a mechanical relay. Now this mechanical relay will not require Arduino Uno or Nano to operate, as it is having just a IC which is programmed with the same program what we see. That IC is directly soldered on a PCB sheet. So that PCB design they have made, and instead of taking a development board, they have directly burned all the program in IC, and then directly it is working. Even it is having the potentiometers over here to adjust time delay, and if I like this, here it is. So it is having a time delay and proximity. So you can adjust it according to your environment. Right? So we'll take a lunch break, and once we back, we'll take with the another sessions. If we are having any questions or a doubt for this session, please do ask.
Sir, can you share all this code on a Google Drive?
Yes, I'll be sharing it.
Okay. Thank you, sir.
Yes. Okay, so I guess there are no questions. Let's have a lunch break, and after a lunch break, we'll resume with other sessions. Thank you.